Hey everyone, we're joined by Gabriele Petronella. Gabriele is the founder of Buildo, a software consulting firm in Milan. He is also a contributor and maintainer of open source Scala projects and the organizer of Scala Italy. Today he is given a talk on MUnits. Could it be one of your new favorite Scala testing libraries? Well, I'm sure, Gabriele, you'll be able to persuade the audience as to why you think it might be.
Thank you so much, Ali. I hope you can all hear me okay. I'm Gabriele. As Ali mentioned, I'm the co-founder of Buildo, a small software consulting firm in Milan. We use a few technologies such as React, TypeScript, and of course, a lot of Scala to deliver custom tailored solution to our customers. So this is what I do by day. And whenever I have some free time, I tend to maintain and contribute to some open source project, especially in the Scala community. So one of the projects that I'm contributing to in the past year is MUnit, which is, as you may guess, a testing library that I want to present to you today. And hopefully I will make it interesting, that you will like it and you will try it. And if you have it already, maybe you will find something new that you didn't know about its design and some internals. So first of all, some agenda. So for today, we're going to see some basics of MUnit. So what it feels like to write a test in MUnit, why, some project information. So then I'm going to move on to why MUnit exists at all. I mean, there are already very fine testing libraries for Scala. They are actually a lot powerful and have been using for years. So there may be a reason why MUnit was born. So this will bring me to the design principles that guide MUnit. And finally, I cherry-picked one of my favorite features of MUnit, which is transforms, which is a very generic term, and we'll see what it means in the context of MUnit. So let's move on to the basics. So it's a very new library. It recently turned 1 year old. It was first released on February 1st, 2020. It feels like forever ago, but it was just 1 year ago. So it was developed mainly by Oliver Gerson, which was then a software engineer at Twitter. He's now a software engineer at SourceGraph, where he's working on developer tools. And you may actually know him for some tools such as Scala FMT, Scala Fix, Metals, MDoc, and a few other really cool tools in the Scala panorama. So it was born, the project was born in the context of these Scala Meta projects. Scala Meta is a sort of an umbrella organization for developer tooling, tool chains and tools. And it kind of emerged as a pattern we will see of needs for testing across all these tools. And then it became a fully refined library that is general purpose. So another few interesting facts about MUnit: it's available for virtually every combination of platforms and Scala versions. So whenever you see not available here in the table, is just because Scala Native is currently not available for 3.0 for Scala 3, but it was actually not available for Scala 2.12 and 2.13 until recently ago, and we already added support. So this shows that MUnit can add support for platform and combination of platform and Scala versions real quick. And this is mainly thanks to the fact that it has no Scala dependencies for its core module. MUnit only shipped a second module, which is the Scala check module, which is the only other dependency that it has, but it's in a module. So the core can move really quickly. And this was also, I think, part of the reason why it was also adopted by some other projects that need to support cross building of tests, because you need to be able to support the latest milestone of Scala 3. It was then Dotty, and now it's milestone 1, milestone 2, milestone 3, and we're recently approaching RC1. So I want to just start with a demo real quick, like first impression of MUnit, so you can get a feeling of how it is. So, so this is the build, nothing fancy, nothing complicated. You can ignore the cat's effect dependencies for now. We will be useful for another example later on. So we just add MUnit as a test dependency, and we inform SBT that you want to use MUnit as our test framework. Other than that, nothing particularly interesting going on here. So I'm going to create a Scala file here. Let's make it a class. Let's call it demo suite of some sort. So there you go. You just extends MUnit fun suite. And then you can start writing right away a test, which is math still works. It's not going to be super interesting, as you may guess. So you just write an assertion that 1 + 1 is equal actually to 2. Let's try to run it. And math still works. So let's try to break it just to get a feeling of how it looks like. So if 1 + 1 is actually 3, it should complain, and it does. As you can see here, it prints a lot of useful information. We'll dig into this later on, but this is essentially how to get started with MUnit. So I hope you didn't hate it so far. It's pretty quick. There's not a lot of boilerplate to get started. You can just write your test right away, and it's hopefully fairly intuitive how to get on with MUnit. So back to the slides. This was just a brief tasting of MUnit. Let's talk about why. So the first thing, when you present something that already exists, I mean, testing libraries in Scala, you have Scala Test, you have Specs2, you have other libraries such as Microtest, Minitest. You have a few different choices among libraries in Scala, and I'm sure I'm forgetting some famous ones. So first of all, at that time, as I mentioned, Olaf was working at Twitter, and he was tinkering with the idea of like reusing the JUnit infrastructure. I mean, JUnit has great support across a lot of tools on the JVM. It's a pretty stable and mature project. It's been around since forever. And so the idea was like, okay, we don't like using JUnit in Scala directly because the API is Java-like, and we don't really feel comfortable using the kind of API. But are we throwing the baby out with the water? I mean, the JUnit infrastructure is pretty cool underneath. If you exclude the high-level API, you can essentially integrate with any existing IDE tool or whatever. So can we reuse the JUnit runner, essentially? So that was the first idea. And then the second idea was like, okay, we've been using a lot of testing frameworks across a lot of different projects. We were using, for instance, Microtest in Metals, but we eventually always ended up writing our own custom API. So we were just using those frameworks as essentially test runners, maybe some basic feature, but we were never using the DSL of any of the features of those frameworks because those kind of projects needed particularly different things, such as Scala FMT needed a lot of customization for printing the diffs nicely because it's about formatting, so you care a lot about the diffs. Metals needed a lot of filtering and annotations in order to filter which tests run on which machine, on which kind of environment. Metals is a Scala language server, which makes the testing infrastructure quite complicated. So it has particular needs. So that was the two main things, like, hey, this thing is general. Maybe we can apply this and get a library. So Olaf started working on this. I personally contributed the cross-building to Dotty. Then I started porting that to Metals, and we were convinced that it was actually useful and maybe not only useful in the context of Scala Meta projects. So then Olaf did his magic, and the project became actually quite cool. And this is the sort of the API that we still have today. So speaking of the API, the design principles of MUnit are actually quite interesting. The first one is that there's possibly one way of doing things, or at least one recommended way of doing things, which I realize so far hasn't been the strength of Scala, but the tide is changing a little bit, and now we're striving for opinionated stuff. We want to have fewer things to think about and more time to think about actually doing the thing we want to do and not deciding at every corner. And the second one is developer experience, which I personally love as a topic and as a concept. And you will see, and I will show you that MUnit is packed with tiny little features that make the developer experience really good, at least my opinion. So first, one way of doing things. So FunSuite, as I showed you, is the only testing style. So this is not necessarily a virtue, as I say. I will take this chance to make a disclaimer. If I'm talking about different testing libraries, such as Scala Test or Specs2, they all have choices to be made, meaning it's a huge, complicated problem, testing in general, and you land somewhere with a trade-off across. One easy thing to think about is like, do you make the project customizable with a lot of features, or do you limit the features and you make the project essentially easy to get started with no options and not anything? So MUnit tends on the second way. So it tends to be a lot of opinionated, as I mentioned. There's fewer ways to doing things. This is not necessarily a virtue, it's just a choice. If you don't like this, I would not recommend a Munit. I would recommend Scala test. So for instance, in Scala test, if you need to choose a testing style because you have several testing styles, including fun suite, which is a testing style in Scala test, which actually inspired the name. So in a Munit, you just get started because you only have one test suite. Fun suite is this kind of style where you write tests and then you just write assertions in it. There's no nesting, there's no DSL, there's nothing. And this is actually connected to the second design principle, which is a second example of one way of doing things, which is there is no matchers DSL, which actually freaks a lot of people out, especially if they're migrating from Scala test. So now I will launch myself into a rant about DSL, so bear with me, but hopefully makes sense to you. And again, this is just different choices and preferences, and if you don't like this, there's a whole world of libraries that you will like. So this is my main gripe with DSLs. Like, the either should be right. It's amazing to read, should be a right, but it could also be should be a right, or it could also be is right should be true, or it could also be is right should be true. There's so many ways of doing the same thing, and I'm finding myself often in a loop where I can't get out of deciding which style to use, and generally the choice feels arbitrary. So this is my problem with DSLs, not only with testing DSLs, with DSLs in general, which used to be very prominent in Scala, and they're nowadays a bit more limited, probably because we were also bitten by this. And I personally, today, after close to 10 years of programming in Scala, prefer just to go simple and do something like assert, give me a Boolean, and I will assert on that, and I will just make that assertion function really cool, and we'll see how it looks like in real life. So essentially, if I can summarize, a DSL is usually really nice to read in isolation. I mean, it's really pretty to read if you read one line, but it's arbitrary choices at every corner. I migrated a lot of Scala test suites to a Munit, and it may be laziness, it may be a lack of guidelines or whatever, but I always find different styles of DSLs, testing suites or whatever, for no good reason. There were no profound reasons to choose one style over another. It was just whatever came easy in that moment, whatever came to mind in that moment. And in my case, it might be my problem, but I know other people that have the same thing, at least I'm not alone. My focus when I'm writing a test often shifts towards choosing the right verb. Is there a better combination for this? Is that a more natural English word that I can use for expressing this concept? Where I'm always doing the same thing and just iterating on the same kind of useless thing in a way, because I'm not doing that. I'm just testing something, right? And finally, this is a minor point, but I'm used to, probably because of the lack of documentation of everything I touch, usually, this is not, I'm used to dive into the code a lot. And if you dive into the code, if you jump to definition of any DSL, you usually land in a mess of syntactic constructs that don't really make sense, and they don't explain what the method actually does. So if you jump on B of a should be, it's probably not very interesting. There's a lot of indirection to get you to where you were going. So again, minor point, but if you like to explore the code, if you have simpler stuff, it's actually simpler to explore and to understand what's going on underneath. Okay, the rant is over. so this is why essentially, Olafur sort of agrees with these viewpoints. I mean, I'm not speaking for him, but we chatted a lot about this. So that's also why it doesn't have, Munit doesn't have a DSL, and it will probably never have it. I mean, it's trivial to write one on top of the existing assertions, but it can live in a different project. And I'm sure some people did in order to ease the transition from Scala test. So now I would like to show you a quick demo again of instead what I mean by DX. So let's go back to the editor and let's write some more things. So let's start analyzing the diff that we've seen before. I mean, this is a failing test.
Gabrielle, sorry to interrupt. Is there any way you could actually zoom in on that and just make that a little bit larger? I've just seen that.
Sure, absolutely. Yeah, is that okay now? Is it readable?
If you could zoom in a little bit more, that might be helpful.
More, like that.
Yeah.
Okay. Thank you so much. Yeah, it's kind of hard to get feedback on these things, so thank you so much. So So as I said, let's start taking a look at this part of the screen. So where the error was presented to us. So there's a few things going on here. They may look obvious, but they're not. So for instance, we start with this marker. So this marker is actually thought for being greppable inside a long log. So suppose you're looking at this test not in an interactive fashion by using the log of a CI. So you want to be able to quickly grep these failures, so to jump from one to another. So again, this is a very tiny thing, but it actually makes a lot of difference when you're doing this kind of work. So this is the symbol that we use for failing tests. There is one for success test, which is a plus, which you can see right here. And there's another one, which is for ignore tests. You can find these documented on the website, and whenever you need them, it's super quick to jump from one failure to another if you need to in a long test list. So another thing, it just prints the name of the suite. It prints the time that it took to run the test, which it's a default that I think makes a lot of sense. I mean, sometimes you have to configure these things in existing frameworks in order to print them, but it's actually quite cheap to do it, and it's very informative if you have a long-running test which you want to debug. Then it prints the path which you can use to jump into the editor, so it's quite convenient. And then it prints a code frame, which actually gives you context on where the assertion failed. So there is some macro magic going on to get the position. It's actually quite simple. It works also in Scala 3, so nothing scary, but it actually gives you a lot of information. If you're, again, working on this in a non-interactive environment, at least you can get the idea of the context where these happened. And then it prints a diff, which may not make a lot of sense, So let's make another example here. So, I mean, makes sense, but it doesn't make, it's not that exciting. So let's try to do something like this. Let's write a user class, which has, I don't know, a name, string, some info, which are info. So again, something really simple, but nested. So, okay, so let's now write some. Suppose you have a method that returns a list of these things. So you have a user, which is me, info 31. Suppose you have another one, which is partner, which is 32. And then you have your obtain. Again, not very exciting. So, okay. So this test would actually work, as you may expect. And let's try to change something here. So let's try to make this age wrong. So it's 20 instead of 32. So you will see here that this diff is actually quite smart. It prints the exact line where the diff was changed. It's pretty printed. And it actually shows you also the name of the property in the case class. So it does a few things for you that you may not even notice, but are actually super informative and super useful. And these were a lot of work to make it work like this. So it also prints a copy pastable obtain value. So you can actually copy this into the obtain thing, because maybe this is a sort of an Oracle test where you just want to have a value and compare it with a known value. Maybe you're just fixing the test itself against the new updated value that you're okay with. You can just copy it there and it will work. So it's super useful if you're working on these kind of tests. So another thing that I want to highlight, which I think is pretty cool. So suppose you have user, now it's a class, and you override to string because you're really evil and you want to do something like this. So now you have name. So we're going to need a bunch of new here because this is Scala 2. So now two users are virtually indistinguishable if you print them, because they only print the name. So if they have the same name, they're going to be okay. So the diff here is actually quite interesting, because then you cannot really print a diff because the toString actually just prints the name. But Munit does an extra step and it tells you this. So values are not equal even if they have the same toString. So we know the values are not equal because we compare them. But the toString is actually the same, so you may want to check out that toString, or you actually want to check out those values. So it goes an extra mile to help you and to explain what's going on, because they may be something not obvious is if I just say, hey, there's no diff, but they're different, right? you may have faced some similar situation, like expected int, and you gave an int, something like that, and then there's something more going on because the string that was printed was actually not accurate. So those are a few things that I think are pretty cool. Okay, so let's move on to another feature. So let me just go back real quick to my slides, which is transforms. So transforms, as I mentioned, is one of my favorite features of Munit, and it is the way we integrate with other features, and in which Munit provides some of its features by this construct. So again, let's switch to a demo. That was not a really interesting set of slides. So let's go back here and notice one thing. So we can get rid of this. We don't need it anymore. So Munit ships with an interesting thing, which is that if you write assert equals 1 plus 1 is 3, it will fail the test. But it will also fail the test if you do something like this. Whoops, this is I imported the wrong one. I blame these on metals. Okay, so if you do a feature successful of this thing, it will actually work. Meaning you're returning a feature and Munit is able to look into the future, run the future, and run the expected assertions. But if you do something slightly different, which is IO from cat's effect, and you wrap this, actually doesn't do what you would expect, because you're returning an IO, which is a value, which you are now running. If you are familiar with IO, IO is a lazy value. So this is equivalent of returning 2 to the test, which will make the test pass anyway. So you're never actually running this assertion. So what can you do? So welcome transforms. So transforms, which is also the way future works in Munit, is essentially a transformation that you can apply at some levels of Munit, different levels. So we will see the first one, which is Munit value transforms. So you can provide your own transfer by overriding the default Munit transforms. So you can just append a new one, which is a value transform. And value transform takes a name, which we will call IO, and then it takes a partial function. So it will actually allow you to match on the result on the value of a test, because tests return value that then get run by the framework underneath. And if this is an IO, so we don't care about the types here, you will just run the IO and turn it into a future. And then the future transform will kick in, and you will get your failure. So here you can see actually another feature. So this is a pretty long stack trace, because you're going through all the internals of cat's effect, but you can see that the failure happened here. And I'm gonna take this chance to, sorry, I'm jumping up and down, I hope it's clear. But I wanna also, I'll highlight another feature of Munit that falls under DX. You see that all these stack trace entries are gray, whereas the interesting ones, which are the ones from our project, are highlighted. So this is done by Munit, which allows you to quickly see which parts of the stack traces you essentially own, and which parts are instead come from separate libraries, such as internals of the cat's effect or internals of the Scala collection library, and so on and so forth. So this feature was actually inspired by microtest, which has a similar feature. And I think it's quite cool. It allows you to debug much more easily a failure in a test, because you can see you have a couple of entry points where you can look for it, and it's probably something over here. But then you can see again that you fail on this assert equals, which is obvious why it failed. So you can do different things, different transforms, as I mentioned. So now we just added support for cat's effect. That was that easy. And actually, there is an official Scala cat's effect integration by type level, which I encourage you to check out. We're in the process of documenting these on the Munit website, actually. And the actual integration is no different than this. It's actually the same code. It handles also sync IO, which is a different data type, but it's actually the same implementation. So I'm not making this up. So we can write integrations for existing libraries in as little as 5 lines of code, including all the boilerplate. So it's quite cool. Another example is a tense transform. So we can do tense transforms, as you may guess, to transform the entire test. So suppose you want to write a test transform, for instance, to print alongside the name of the test, the version of Scala that you're running this test on. This was actually a transform that we needed in Metals, because in Metals, we have some parts of the code that test across different versions of the Scala compiler. And it's interesting to know which version failed in a CI log. So this test may fail on 2.13, but it may actually succeed on 3.0, M2, something like that, right? So we can actually do this here real quick. So we have a new test transform. We call it Scala version, whatever. And then you get a function from test to test. So you're just getting a test. Let's call it T. And then you can just do, you know what, this test will have a name. There are some smart constructors on tests to perform changes. So the name will actually be the test name, but we also appending, it should be something like properties, compiler, something like that, version number string. There you go. So now whenever the test fails, you can see here that it actually prints 2.13.3, which is the version running this test on alongside the test. Again, this is an example, and it's quite convenient to do, and you can do a lot of things with these constructs because you can just manipulate tests and the test suites as values. And we don't have the time right now to go into it, but it's not very interesting because it's very similar, but you can actually apply this transform also to the suite level. So you can change stuff at the suite level, like doing some filtering or some reasoning about the entire list of tests that you are about to run. So for instance, you may want to exclude an entire suite from running on, I don't know, Linux, because you know there's a problem and you just want to avoid running the entire suite on Linux. We do have a few of these things in Metals. There's another feature in Munit that I didn't mention, which you can annotate tests with metadata. So if you do that and you combine it with a test transform, you can actually annotate these tests and say, okay, this test is a test that shouldn't run on Scala 3. And then you have a transform that takes this metadata information and it says, oh, this test shouldn't run on Scala 3. So let me just exclude it from the list of tests that this suite runs whenever we're running on Scala 3. So you can do all these kind of transformations with a fairly simple API. It's just a transformation. It's essentially a map we're all familiar with. And it's quite cool that you can integrate with libraries, do custom things on your test suites with, again, a very, very, an API surface that is actually very contained. So back to the slides. I want to just mention, like honorable mention, I didn't have time to put all of these in the talk. Some other cool features that I think are really nice. So there's this concept of reusable fixtures. You may be familiar with the after, before each, and after each from test suites in virtually every other framework, testing framework. And Munit actually does something clever. You can have these things as values. So you can have a bundle which includes after each, before each, some setup, some tear down functions, and you can reuse these fixtures in order to perform actions before and after tests, single tests, a group of tests, and these kind of things. So again, treating these things as values and treating the tests as values allow you to compose these things orthogonally and do pretty powerful thing with a very limited API. There's Flaky test management, which is one of my favorites. It was kind of a hard pick to go for transforms, but Flaky test management is quite cool. You can annotate a test as Flaky in Munit, and you can do a few things like leaving the test run, but if it fails, not fail the CI run, for instance. You may let it fail locally, but it will not fail the CI run. So if you're suspicious that a test may be flaky, you can just do that, and then Munit is capable of producing a report that you can. There is an kind of ongoing integration with cloud providers. We used to have one in Munit. It's currently under redevelopment, but the idea is that you can publish this information and monitor the runs of your tests from your CI, and you can then decide whether the test was actually flaky or not, because you're still running the test. So if you have something like this test fails 1% of the time is probably flaky, but if you fail 70% of the time, there's probably something going on that you should look into it. So it's not hiding things under the carpet. It's actually useful if you want to have confidence in your CI doing so. And then you have some minor features which are pretty cool. You can mark tests as expected to fail. So it will fail the CI if the test passes. This is useful for committing reproductions of bugs that you don't have a fix for. I actually did that a few times with Metals, and recently, for instance, yesterday a PR was merged that fixed the bug, so you were actually forced to go and make the test pass instead of fail. So it's quite nice. It was actually inspired by Ava, which is a Java testing framework. And you have assertion clues, which if you run plain asserts, you can annotate parts of the expression that produces the Boolean that you're asserting over, and it will actually print those information for you, the value of those information. This, again, is documented on the website, and it's what makes assert, not even assert equals or the other asserts, but just the plain assert function that works on Boolean. Very interesting for producing readable and actionable results if the test fails. And finally, this is one of my favorite, which is the Scala check integration that I worked on. Scala check is quite a snowflake in the Scala in the Scala testing library community, because it's virtually used by every project, including a lot of famous projects. So it's quite crucial that MUnit ships with a Scala check integration in order for other libraries to migrate over. So MUnit provides out of the box a single module, which is a Scala check integration, which works, by the way, exactly with the same transforms that I've shown you before. So again, we're dogfooding a lot in MUnit itself, and it I think it shows that it's quite powerful. So again, thank you so much. That was what I have. If you want to get started with MUnit, there's a website with a lot of information that I try to compress in half an hour here. And well, there's some other references if you want to get in touch with me. Thank you, and I'll see you, I guess, in the Q&A room.
Yes, thank you, Gabriele. If you would like to head over to the happiness room on the spatial chat now, I'm sure there are a few questions. There's lots of chat happening in Discord. So if you guys head over there now, you can all have a chat. Thank you.
Okay. Thank you so much.